Hello class, this is a video tutorial on data collection in statistics. So in data collection, there's really only two types that we can go about to collect data. That is a census and a sample survey. The census is very straightforward. Sample surveys can get a little tricky. They can be further subdivided into different kinds of sample surveys. Let's begin first with a census. A census collects data from the whole population you are analyzing. So not to get confused with population, because what the population is changes depending on what you are analyzing. So for example, if we are studying car manufacturing errors, we would run a census on all cars made. So in this first example, the population is not everyone in Australia. The population is all the cars made, because we are studying car manufacturing errors. Yeah, this is the one that we were thinking of. If we are studying the well-being of Australians, we would run a census on all of Australian citizens. Okay? And if we are studying year 7 students, a census would question all year 7 students. Okay, so once again, the population, what the population is, changes depending on what we are studying. Now, the good things about censuses is that they are very accurate and detailed in the information that we gather. Okay, because we're getting absolutely everyone. We're asking absolutely everyone the questions. And so we'd expect it to be very accurate and very detailed. But the bad things about it is that it's very expensive to be able to question every single person. And it's very time consuming to do the same. Okay, which leads into the next kind of data collection. It is sample surveys, and as you can probably already tell, it is a sample of the population. So a sample survey collects data from only part of a population. So going back to our first example, if we only took 100 cars tested for every batch of 1,000 made, so let's say 2,000 cars were made, we would only test 100 from each of the 1,000. So that'd be 200 cars tested. If we were to look into the census of Australia, rather than that, we could ask 1,000 families from each suburb. Okay, this is a good point. This actually leads into a particular kind of surveying. This is called stratified. Stratified surveys. And we won't be exploring that in this video, but in a different video, you can find that in my playlists. And finally, if we were to, rather than study every single person in year 7, we could just ask 10 students from each year 7 classroom. Okay, so obviously the good things about this, it's much cheaper, okay, and it's much quicker. Rather than ask everyone, just ask a few people. But the bad thing about it is that it's not as accurate, and it may contain error and bias, or bias. And we're going to look further into what this is here. So in summary, we have a census and a sample survey. Okay, moving on. So we're looking into bias in samples. Okay, so bias is an inclination for or against a data analysis which skews the accuracy of the results. So pretty much anything that may make the results go in one way or the other. Because remember, we want results to be as accurate and fair as possible. Okay, so for example, let's say I were to ask a bunch of people, rate how good the Tigers are, okay, so the NRL team, are as a team. 1 is bad, 5 is good. If I were to ask only people from Southwest Sydney, which is where most Tigers fans are, okay, you'd expect that the positive you'd expect the results to be positive, showing lots of 3, 4s, and 5s, because I asked people in a particular region. Whereas if I ask people only in Parramatta, okay, Parramatta that's where Parramatta Eels are from. So as a result, you might expect the Parramatta Eels to not rate Tigers as much. So there is bias in both of these examples. Okay, bias can result from, the first thing we can result, unequal representation of the population. The best example I can give for that is, let's say we ask the question, are women good drivers? But if we were to only question men, okay, the results will be very, very biased. Because if you're asking about women, you should ask women as well. That's just one example. Small sample sizes. Okay, let's ask, if I were to ask, pizza is the best food, but I only asked 10 people for that, then I use that result to say, oh, pizza must be the best food. That is a very, very biased example. Our sample sizes should be larger than 10. Okay. There could also be personal preferences of those that construct the questions and those that answer them. So, for example, the person who surveys, so the surveyor, only asks their group of friends to answer questions. Well, if the person asking the questions asks only their friends, you can clearly see that the results could be very, very biased. And finally, time and location of surveys. So, for example, if we did phone surveys, all right, during the day, let's say between 8 a.m. to 3 p.m., well, that's an unfair bias because most people are working between 8 and 3. Okay, so not many people can actually answer the questions. Okay, so now let's take a look at whether we can see and determine, okay, what biases may result in these questions. Here we are, a phone survey on a Monday morning. Well, the first thing we could say, that's a time bias. Okay, we could say that most people work during the morning. Okay, we could also say that there's a mood issue. Okay, it's a possible one. I'm not saying it will be, because on a Monday morning people are a bit grumpy. So grumpy survey takers. So the people who take the surveys might be a little bit grumpy, so their results would not be as accurate as we want them to be. Okay, the survey of people at a train station. Well, as we can see, it only includes people at train stations. What about people who take buses, people who take cars, people who walk? So this would be I would call that a location bias. Okay, this does not include others who take other modes of transport. Okay, a survey at a rock concert. Well, this has a bias towards people who like rock music. This has, this would be preference and location as well. This has, bias for people who enjoy rock music. Okay, because we don't want, well, it depends on what question we're asking, but we don't want our sample size to be just people who like rock music. We want as wide of a variety as possible. And the last one is 15 people tested with a new medicine. Okay, this is a sample size issue. Sample size. Okay, the results show a bias to the physical characteristics of the 15 people tested. Okay, so what if those 15 people were only men? What if what if those 15 people were aged 30 to 40? What about people who are 10 to 19, for example? So I hope that this is a good start for you to understand the different methods of collecting data for a data analysis. Best of luck.